Thank you very much for the opportunity. We are very, very happy to be present here and to have the opportunity to talk about our technologies and solutions to you. And I must say, I really appreciate that you went in the room from that wonderful sun outside when nobody really wishes to come in a meeting room anymore. We will talk about different gas solutions, actually one solution offered by Cason for gas distribution companies. I'm the CEO and president of Cason, and we define ourselves as the gas distribution network management company. Everything we do is related somehow with gas distribution network management. We are not a large company, we are 74 altogether. We founded the company 22 years ago, and you can see that we are quite nicely spread in the world. We have our own daughter companies, and we have many, many motivated partners, like the one in Croatia, ex-agent, who are present here, and you can also find us on the booth out of the room. What we actually do. We manufacture some special transducers, extremely low power transducers, in order to operate for years from batteries. Then we install them nicely in your gas transfer stations. We also manufacture compact RTUs, which are explosion proof. Install them in less than 2 hours time. Then we connect to the existing gas volume correctors. And when the job is done, then we take our phone and check the results. So we should observe pressures, input and output pressures, and gas consumption data like indexes and flow rates, then valve positions, security valve positions, and gas temperature, and a lot of other parameters which are related with the field system, as like the RTU, to see the battery status, to see the temperature of the RTU, everything which is needed to really operate in an efficient way the field system. Actually, we have time enough. I will show you something interesting. This is my phone, and we will see online and real life. It's not a presentation, it's a real one, how all this system is working. If Mr. Murphy will help us to have it running. What you see here, it's actually the SCADA system. Looks like. I have the sites, I see my gas transfer stations, I see my pressure regulation stations. I see that there are no alarms and warnings at all for the time being. In the winter we'll have most probably. The people operating the platform, they are quite active because we have 15,000 user events. They could also switch the language of the interface to another language. I really hope so that in a very short time we will have the Croatian language also listed on between the possibilities. But to show you something more interesting about that, I will show you a slide with real life data. And being in Croatia, we will take a site from Varaždin. It's a gas transfer station of Thermoplik, who were nice enough and very kind to start up a pilot with us some actually days ago. What you can see is that the last information from the gas transfer station we got 10 minutes ago around. They had quite a nice flow rate, 266 cubic meters by hour, and a pressure close to 4 bars. If I would be operator of this network, actually this data would more or less be enough for me to see every day when I want to see what is the situation there. But if I'm more curious, then I can dig a little bit down in the data to see the details. And what we see here is the input pressure around 4 bars, and you can also see the variation of the pressure in the past 24 hours. The same with the flow rate, and you can see it was a gap today in the flow rate, so most probably they slow down because of any reason, the consumption, and so on. I have all the interesting data as indexes, as temperatures, as error register of the corrector, which indicates me that the corrector is okay and the pressure and temperature measurement is okay, and so on. So if I'm even more curious, then I dig down in this flow rate and see what happened today. And you see, turn it a little bit like this because it's easier to see. And we see that they stopped at 9 o'clock in the morning for 1 hour, and they started up consuming again. And if I'm really curious, then I will have a look to the consumption table hour by hour. Actually, it's the allocation for today. So I needed nothing more than my phone to that. So that was not a presentation. Actually, it was a real life example of how this system looks like. Of course, this data is available for your tablet PCs, making no difference whether this is an Android tablet PC or Windows tablet PC or an Apple tablet PC. And of course, it's available for your computers, making no difference whether it's Windows or Mac or whatever else should come in the future. All the data, what we collect from the field, they are stored and processed in the Microsoft Cloud. If you wish, we can establish your own cloud server, but usually it's stored in the Microsoft Cloud, and you get back the result as data services. Actually, we supply alarms, warnings, trends. This is called SCADA. And the picture what you see below this is the dispatcher room of one of Gaz de France, who are dealing with some good thousands of gas transfer stations, and they are using our platform. You can see how it looks like. Actually, it's a real, very strong SCADA. We also produce the most important documents. When I was a young engineer, I was thinking that the online interface is a lot more important than documents. Now I'm 55 and I realized that the documents has to be more important than the online interface. So what you see here are the allocations, what we produce for the gas distribution company. As you can see, it's a very straightforward document, and we send it every day for every POD, for every group of consumers in Excel and PDF format. If you want to change something, use the Excel. If not, use the PDF. We do the nomination as well, which means we do the forecasting of the consumption of that customer or group of customers for tomorrow. It's an endless story, but it's a high-level, very sophisticated mathematics behind. It's called a support vector machine. So mathematics based on neural networks, and we do our best to guess as good as possible how much the consumption of that customer will be tomorrow. When the day passes, in 2 days' time, we can compare our forecast to the reality. And this is what we call nomination analysis document. So what you will see is what nomination errors we made 2 days before. Even more direct, you will see how much penalties you will pay end of the month because of not very precise nomination. Actually, you cannot get rid of penalties. We should consider that penalties are kind of a cost of the gas distribution. But it can be optimized to be as a minimum. And there are statistical methods that can do that, and then we save a lot of money. And we also produced the profile document. Actually, a profile is a documentation of a customer, of a consumer. Having a look to some trends, some charts, we have a very clear idea what kind of customer is that. If you have a look to these charts, this is the daily average behavior of this customer from Romania, winter time, and the other one is in summertime. As you can see, they consume during the morning and the evening, so most probably they will be using the gas for heating. And if you have a look to the trend of the summer, you will observe a small peak midday, which means they're also cooking. If we have a look to the week profiles, then we see that they are consuming all the week long, except Saturday and Sunday, when it decreases, which means that it must be a kind of institution or industrial enterprise having less consumption during the weekend than they are consuming at home. And we can also see the difference between summer and winter. And end of the day, we have the profile of the year, showing more or less the same. But it shows me something very interesting. It shows me what is the average monthly consumption of this customer. So if you have a look to this profile, you see this is a really valuable high-class customer, doing nothing crazy, consuming very nicely and predictable, and consuming a lot, which means that we'll also pay something.